Hey everyone, welcome to this project. It's going to be called ElectroBike, and over the course of the next year, we're going to be making an electric bike that goes super fast, has a really strong motor, and it's going to be a great time to ride. So before I get into this project, just a few words about myself. My name is Misha. I'm a senior in mechanical engineering, and this is actually my second time PMing. I led this team, led this project last year to build a four-axis robot arm to act as a cooking assistant. And we, in this shot, you can see it stirring pasta sauce. And actually, this night we also stirred pasta with it, and which helped us create a penne alla vodka dish, which turned out fantastically, and we all ate it together, which was really fun. But getting into some of my hobbies, so over this past summer, I've picked up mountain biking and I've been really enjoying it, and that's kind of the inspiration for this project. Um, and also, I'm not super serious about it, but rock climbing is something I really enjoy doing with friends, and yeah. So kind of getting into the actual project itself and the motivation for something in the biking space. It's that it is an inexpensive, healthy, and non-polluting way of commuting, and like compared to a car, for example. And also, it is, in my opinion, a very good way to experience nature. It's similar to hiking, but you can just see a lot more stuff if you are on a bike and are able to travel further distances. So that's part of why I really enjoy biking. But there are issues that arise with it for when you're trying to commute for longer distances. Like for example, if you're commuting, like something that normally takes a half hour by car is just going to turn into a daunting exercise and not just a simple commute when you're on a bike. And also when you're in places like San Francisco or around UCLA, there's going to be a lot more hills, so that makes it kind of a miserable experience potentially for commuting. And that's where electric bikes come in with the extra power. So something you might be asking though is, can't you just use a rideshare e-bike from like Lyft or Divvy, since they're conveniently placed all around the city? But and you'd be right about that. But the only issue I can imagine or I see is that they have only 500-watt motors, and I think that's just not going to cut it for makers. We need something a lot more powerful, something more fun to ride. So what I'm thinking is we're gonna strap on a 2 kilowatt motor, so about 4 times as strong as a lift bike, and we're gonna um attach it onto a used bike that we're gonna find off of Craigslist or like OfferUp, Facebook Marketplace, somewhere cheaper, so that we can really focus all of our funding on the motor. And yeah, this way we don't have to worry about building the bike in the first place, since uh that would extend far into like a multiple year project. But yeah, this way we can just focus on the integration of the motor and the bike. And then also we can play around with adding a user interface, something to make the bike smarter, more user friendly. Here, for example, is an example that that Yvonne actually gave me earlier, and it's that we could put these like buzzers, these vibrating motors on the handlebars to indicate when the user should be turning. So that might be like a way to navigate without having a screen or like be distracted by Google Maps while you're on a bike. So just a cool idea. But yeah, and the things that we will learn are mostly going to be in the mechanical space. So there's going to be a very involved design process. Um, which is going to involve a ton of brainstorming for how we're going to put the mechanism together, bunch of like lateral thinking, that kind of stuff. And then we're going to get into CAD. We're going to make a full-fledged CAD design of the system so that we can, once we get into fabrication, make everything precisely and have everything fit together and just run really smoothly. And which is actually like going to be really important, because if we're traveling at really fast speeds with a lot of torque, especially if it's a used bike that is not going to be, or like a cheaper bike that's not going to have maybe the strongest materials, it's really important that we make it right so that it is safe and doesn't break itself. But yeah, yeah, and I should stress that safety and making sure that everything like doesn't blow up is going to be our top priority on this project. And then another kind of area that we'll learn about a lot is power electronics, because this is a high power system with something that's going to be probably like a 48 watt or 48 volt battery. And we're going to need to like manage that and not have power losses in some components, that kind of thing. And motor control is going to be a really interesting area, because we're going to need to control the motor so that it accelerates, decelerates at a predictable rate, so that the bike doesn't just like suddenly jump up to full speed and pop a wheelie and like the user lands on their back, that kind of stuff. And yeah, so and then the final area will be microcontrollers. So as I mentioned, with those like little gadgets at the front on the handlebars, some kind of user interfaces, um, and sensors, and there's also going to be some kind of feedback mechanism to know how fast like the wheels are spinning, that kind of stuff. So all around, we want to make this bike an intelligent system that kind of provides a lot of readings, um, so that the user has the best experience. And yeah, I think that wraps it up for this project. Thank you guys for listening, and feel free to contact me at this email with any questions or anything like that, or if you just want to chat. I'd be fully open to that. Okay, cool. Thank you.